good news is what we are doing today is very much like what we did yesterday. So if you understood what we did yesterday, today should build directly from that. We're adding one little twist today, and then tomorrow we'll add a second twist. Okay, and then we're done learning new material for the entire year. So keep that in mind as we work through things. We're getting close. Given this graph, f of x equals cosine x and g of x equals sine x, we're trying to find the area of the shaded region. Just the area. Nothing fancy here, just area. How do we find area? We integrate. Okay? To find area, all we got to do is integrate. This is my shape. We already got the shaded region. Obviously, this is cosine x because it starts at top, and that's sine x because it starts at 0. What would be, we get to decide, would we rather make this a dx problem? Would we rather draw vertical lines, or would we rather draw horizontal lines? Vertical, because if I go vertical, it's blue to red, blue to red, blue to red the whole time. Okay, and then also I just have to make them y equals equations, which they already are. I wouldn't want to change that. That would be annoying. Okay, so we want to leave it just like it is. That's cosine x, and that's sine x. We want to go those two. So if we're going vertical lines like that, that makes this a dx problem. My lower bound is 0. What's my upper bound going to be? Pi over 4. That's the x value where that stops. We started at 0 and went to pi over 4. Then what we need to do is set up our bound, or set up our integrand, the thing inside the interval. Okay? We drew vertical lines, so we want to go top minus bottom. So Slade, what did you end up writing there? Cosine x, that's his top line, minus the bottom line. His bottom line is sine x. Boom. That's my setup. If this were a free response question, that's getting me at least 1 point to set that thing up. Normally, we would just type this into our calculator. We are going to do this by hand, but it's not that hard here. Okay, we're going to find the antiderivative. Dylan, what would the antiderivative of cosine x get me? That is sine x. He's doing Snapchat, negative Snapchat. He went from right here, cosine. He went back a step. He got sine. Luke, what about negative sine x? That would be cosine x. Good. We're going from negative sine x. We're going back that way. It'd be a positive cosine x. We had this discussion earlier. Which one do you want to treat it as? Do you want to treat it as sine, or would you want to treat it as negative sine? You're going to get positive there. Don't overthink it. Okay? We're evaluating that thing from 0 to pi over 4. So all I got to do is plug it in. Sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. What did I do wrong? Parentheses on that guy. Sine of pi over 4 would be square root of 2 over 2. And cosine of pi over 4? Same thing. That's why we knew that was the intersection point. That's when sine and cosine are equal to each other, because they're both square root of 2's over 2's. Minus sine of 0 would get me 0, and cosine of 0 would get me 1. That could be my answer. I could leave it just like that and be perfectly happy. I've got 1 square root of 2 over 2 plus another square root of 2 over 2. That would get me 2 square root of 2 over 2. Or in other words, square root of 2 minus 1. That would be the simplified version. But again, if this is a free response question on the AP exam, leave it just like that and score full credit. Questions with something there? Let's do an important bell work part 2. Look at that shape right there. If I were to ask you to find the area of the yellow region, talk with your neighbor, what would you do to find the area of that yellow region? Anybody have a good way of finding the area of the yellow region? Michael, what do you think? Find the area of the whole circle. What do you mean by the whole circle? The entire thing. The big circle. Everybody agree with them on that? We find the area of the big circle. Okay? So it'd be, what would your radius be of the big circle? 3. And then what else would you do?
Subtract the area of the smaller circle.
You would minus the little circle. The little circle, what would my radius be? It's 1. If we took the area of the big circle and we subtracted out the area of the little circle, 9 pi minus 1 pi would tell me the area of the yellow shape, which would be 8 pi. Good with that? That's exactly what we are going to do today. All right, that's going to be the exact same thing we're doing today here. All right, so here's what we got. We are taking a shape, so it's hard to see it here, but we're taking this shape right here, and I'm revolving it around the x-axis. If I did that, it's going to give me a washer on the inside. The way I can tell that it's going to get me a washer, it's because it's this shape right here, and it is not directly against the line you're revolving around. See how there is a gap right there in between those two. If there's going to be a gap, that's what's going to get you a hole in the middle of your shape, which is going to make it a washer. All right, we talked about this just a second ago. To find the area of a washer, well, that's what was on our screen. We found the large circle, pi big R squared minus pi of little r squared, the big radius minus the little radius, the big shape minus the little shape. We could write it just like this. That would be perfectly fine. But if we wanted to, you can notice here that each thing has a pi in it. So if they both have a pi, you can factor the pi out in front, and it makes it a little less complicated. Okay, it just makes it a little bit easier to type into our calculator. Everybody with me so far? Let's do it. So I used to draw really complicated pictures like this one. I'm not going to really do it that much anymore. I feel like the less complicated we get, the easier it is to understand. Find the volume of the solid by revolving the region in the first quadrant bounded by cosine x and sine x. So exactly what we just did. Okay, so this red line is cosine x because it starts at 1. This blue line is sine x. And we're revolving this region right here. Okay, this is the shape. We are revolving it around the x-axis. So we're revolving it around that line right there. Does it make sense that this shape, when I revolve it, is going to get me a washer? Yes. How can we tell that? Well, the reason we can tell that is because there is a gap in between the bottom of that thing right there and the line we're revolving around. If it's not flush up against the line, if it's not touching everywhere around the line that you're revolving around, it's going to make a washer. Okay? In this case, that's what's going to be true. What happens if I were to revolve this thing around the y-axis? What type of shape would this make if I revolved it around the y-axis? A cone. Would it be a disc or a washer cross-section? A disc, because it's touching everywhere on that line. Do we see what I'm saying with that? All right. So this is going to be a washer because there's that gap. Let's set it up. We're finding volume. How do you find volume? Integrate the area. Show me with your finger. How are you revolving around this axis? The x-axis. I'm revolving around the x-axis this way. So if I'm revolving around the x-axis this way, that makes it a dx problem. All right. You're drawing perpendicular lines. You're going this line around the x-axis and that line. Okay. You've got this line that's going to go around. There's one radius, and there is a second radius because there are two lines being revolved around that line. I think that's important to understand. Cool. It's dx. We got to do bounds. My lower bound is going to be 0 because I'm starting right here with that x value, and I'm going to that x value of pi over 4. The only thing I have left to do is decide what is the shape that I'm going to get as a cross section. We identified this problem as a washer problem. And we just a second ago said to find the area of the washer. Okay? It is pi of big R squared minus pi little r squared. Pi r squared. You're going to have a big radius and a little radius. Okay? If you're smart about this, we'll factor that pi out here in a second. But we got to figure out what is the big radius and what's the little one. When we say the big one, it is the line the furthest away from the axis we're revolving around. Which line is furthest away from the axis we're revolving around? Cosine x. So that is going to be my big radius minus the line you're revolving around. What line am I revolving around here? 0. So it is cosine x minus 0, otherwise known as just cosine x. The little radius is the inside line being revolved around the axis. Okay? So the little radius is going to be this guy revolved around 0. So it's sine x minus 0. Yes, sir? The 0 doesn't really matter, right? It's just 0. But that is the line I'm going, top line minus bottom line, right? We're still using that same idea. The radius that I'm making here is going from the top line of cosine x to the bottom line, which would be 0. The reason I'm writing 0 is because tomorrow we're not revolving around the axis. And so if it starts to get into your brain today, it'll be easier tomorrow. All right? So, again, we're setting this thing up. They both have a pi in it, so I can factor a pi out. We're going big R squared, so that is cosine of x squared minus the little r sine of x squared. Type it into your calculator, get an answer. Look, when we look at this shape, again, here's what we got. Okay, we've got this little region right here. We're revolving it about the x-axis. So if I revolve it around the x-axis, it's giving me this shape right here. Okay, it's a weird looking shape, but that's what we're getting. Okay, I revolve it all the way around. It's kind of like a little mound that's been drilled into on the top. Okay, that's going to be my general shape if I were to complete that thing. Okay, to type that into my calculator, I do this right here. Pi out in front, 0 to pi over 4. Cosine x squared minus sine of x squared. Make sure you got the parentheses in the right spot. Make sure you've typed everything in correctly. How many decimals do I go to? 3. My answer is 1.571. Questions on example 1. Let's go to the back side. Example 2. Find the volume of the solid by revolving the region in the first quadrant, bounded by the curves x squared and square root of x. Which one of these, red or blue, is x squared? The red one is, obviously. This is cosine x. I'm just playing. No, it's not. It's x squared. And then the blue one here is going to be the square root of x. This time, we're revolving around the y-axis. So this is the y-axis. That's what I'm revolving around. So I'm taking that shape and I'm revolving it this way. Okay? I'm revolving it that way. Is this a disk or a washer problem? It's a washer, right? Because you're revolving two lines. There is a big old gap right here. Okay? That gap matters. We're going to have a big radius there that goes from the middle line to the outside line. And then we're going to have a smaller one that goes from the line you're revolving around to the inside line. I've got a big R and a little r. Everybody with me so far? We're finding volume. How do you find volume? Integrate the area. We got to put our area right there. We are revolving this way. So if we're revolving that way, are we perpendicular to the x or the y-axis? The y. So that makes this a dy problem. From when until when are my bounds going to be? 0 to 1, because I'm starting down here at this y value and going to that y value. 0 to 1. The only other thing I have to do is write in my equation. We identified that this is a washer problem. So if we're doing a washer, it is pi big R squared, the big circle, minus pi little r squared, the little circle. So we can factor out a pi if you want. Well, let's just worry about the big R first here to start. Big R. That is the outside line that's being revolved around our axis. Jesse, what's our outside line going to be? X squared. Why are you not going to write x squared here, though, for R? I got to have it in terms of y. It's a dy problem. So Jesse can't just put x squared there. Okay, it's x squared equals y. What are you going to have to do? Yeah, we're going to have to solve. We're going to have to square root the other side. So x equals square root of y. That's this outside line here. Okay, that's the outside. That's the big R. If it's the outside line that's being revolved around, that's my big R. We wouldn't need plus or minus because the minus would be the other side. Okay, we could do plus or minus, but I don't need it because it would be the side that I don't really need. And then we've got that. Yep, good. Big R minus the line we're revolving around, so 0. My little r. Okay, that's the inside line that we're revolving around. It's this square root of x, but what do I need to do with it? Solve for it. So I'm going to square both sides. Y squared equals x. So this line right here, yeah, it's square root of x, or we could call it y squared. So my big radius or my little radius is the inside line, which would be y squared minus the line that's in the middle. the center of my circle, which would be 0. What do we notice about both things? What do they have in common? They have a pi in them, so we could take a pi out in front. We are taking square root of y, and we're going to square it. So you could write square root of y squared, but what would be easier to type into my calculator? Just y. You're taking square root of y, and you're squaring it. Just write y. Minus the little r squared. Well, I'm taking that, and I'm squaring it. So what else could I write there? Y to the 4th. Make it a little bit easier on yourself and simplify. Type that into your calculator. Get that picture. So again, we're taking this little shape right here. We're revolving it around the y-axis. So when I do that, when I revolve that thing around, okay, it's going to get me that shape right there. So it's kind of a hollowed out, kind of flower-looking cone thing. I don't know. It's hard to describe that guy, but it's going to make a little bowl. That's what we're getting in the end. When we integrated, when we typed that into our calculator, we should have gotten an answer of 0.94 what? 942. That one should be a pretty easy type in. It's just this guy right here. If you didn't get that, make sure you threw the pi in front. That would be the number one mistake you made. Okay, I'll do it real quick so we can see it. So second pi, math 9. We're going from 0 to 1. We're doing y. You can type in the letter y. I'm just going to use x minus x to the 4th. If you used y, there'd be nothing wrong with that. I just like using x because it's faster. I get 0.942. Questions on 2. Example 3, we're finding the volume of the solid by revolving the region in the first quadrant, bounded by the curves x equals y cubed and y equals 2, and we're revolving it around the x-axis. What do you think you should do first? Graph it. We need to draw a picture. We don't have a picture. We need a picture. One thing that you'll notice here, you might not be an expert at graphing all of these shapes. So when in doubt, just plug in some numbers. All right, if I want to, x equals y cubed, I don't even like that. What could I do with that to make it a little bit more graphable? Solve for y. So it's really the cube root of x equals y. You might be good at that graph. You might not. Plug in a number. What would be a good number to plug into that? I would start with 0, but yeah, you're not wrong. You can plug in 1 too. If I plugged in 0, 0 would get me 0. What happens if I plug in 1? What would I get? 1. If I plug in 1, I'm getting me 1. I'm going to cheat on my y-axis here because I know the picture is kind of small. I'm going to plug in 1. Okay, and then what other number would be a good number to plug in? 8, because the cube root of 8 is 2. So if I went 8, I would get 2. I'm helping myself out there by being smart about the numbers I choose. There's that graph right there. Then the other thing I'm graphing is y equals 2. Show me with your arm, what does y equals 2 look like? You need to know that. It's going to be real important tomorrow. Y equals 2, that's a horizontal line. And so this is that other line. I'm in the first quadrant. So if I'm in the first quadrant, we're talking about this shape. If I'm in the first quadrant, I'm revolving it around the x-axis. So if I revolve this thing around the x-axis, show me with your finger, how are you revolving if you're going around the x-axis? This way, you're going perpendicular to the x-axis. Is this a disk or a washer problem? Washer, because this shape doesn't touch the x-axis. What if I revolve this thing around the y-axis? Would this be a disk or a washer? It'd be a disk because it's touching the y-axis everywhere. That's an important thing that you have to be good at. Okay? Go ahead and try and set this up and solve it. Once you solve it, show me with your fingers the rounded closest value. So we're setting this thing up. We're revolving it this way. I would draw these lines. Draw your radii. Okay? So one of them, the outside line around the line you're revolving around, that's going to be my big R. And then I'm going to have the inside line around the line we're revolving around. That's a little r. That's how I can tell this is a washer problem, because I'm revolving 2 lines around that axis. Okay? It's a dx problem because those lines are perpendicular to the x-axis. We're integrating this thing from 0 to 8 because those are the 2 x values that we're setting up here. It's a washer problem, so it is pi big R squared minus pi little r squared. My big R is 2 minus the line I'm revolving around, which would be 0. My other line would be the smaller line. What was my smaller line? Well, it was that x cubed. Do I want x cubed or do I want y, or cube root of x or y cubed? Cube root of x, because it's in terms of x. So it's the cube root of x minus 0, because that's the line I'm revolving around. Factor out the pi. I'm taking 2 squared minus the cube root of x, which is like x to the 1/3 power squared. Big R minus little r. Everybody with me on the setup? This picture looks like this, just so we can see it. I think it's helpful to see what's going on. So we've got that thing right there. We're revolving around the line. Eventually it'll go. Maybe not. Maybe my computer hates me. Oh, there it goes. So it's like a flat cylinder on the outside, and you can see how it's kind of like got a hole there in the middle that has been created as we kind of like think about like a drill bit kind of going into the wood there around a cylinder. That's the shape that's being made. It won't let me rotate it. Questions with the shape? We typed that in. You should have gotten 40.21. What'd you get? 40.21 what? 40.212. Questions there? Let's do one more. We'll go a little bit quicker here. You guys are doing well. Find the volume of the solid by revolving the region in the first quadrant, bounded by the curves y equals x and y squared equals 4x about the x-axis, or y-axis, sorry. The hardest thing about these problems is just being able to graph it. If you can graph it, if they give you a graph, these should not be hard. Or not as hard, I guess. Someone got mad at me yesterday because I said too many things were easy. It's just me trying to be nice to you and try to make you feel confident in what you're doing. It's not anything beyond that. Y equals x. If we're graphing y equals x, that's a line that goes like that. Y squared equals 4x. I don't like that. What should I do with y squared equals 4x? Yeah, I'm going to get y by itself. And so it's going to be y equals the square root of 4x. I'm not great at graphing that. Okay, you could simplify that and say that's y equals 2 square root of x, or you could have done a bunch of different things, but I'm just going to plug in some numbers. What would be a good number to plug in? 0 is 0. 1 would get me 2, and then I would want to take the square root of 4, which would get me 2 times, oh, that would get me 4. So my shape is going to be that guy. This is the shape bounded by those two lines. This guy right here. You're revolving about the y-axis. Show me with your finger. What does it look like if you're spinning around the y-axis? This guy. Okay, you're spinning around the y-axis. You are making a disc or a washer here. Which one? Washer, because you've got an outside line that's revolving around. That's that guy. That's going to be big R. And then you've got an inside line that's going to be revolving around. That's little r. Find me an answer. Here's my shape right here. I'm taking it. I'm revolving it around the y-axis. So it ends up getting me kind of a cone on the outside with kind of a drilled in inside there. That is giving me that washer shape. How do you find volume? You integrate the area. If I'm revolving that way, am I perpendicular to the x or the y-axis? The y, it's dy. I'm integrating from 0 until this y value right there of 4. It is a washer. We discussed that because I'm rotating two lines. So it is pi big R squared minus pi little r squared. My big radius is what I get when I take this outside line and rotate it around 0. What should I write, y or x? The y, because it is a dy problem. So that's my big R. My little r here is the inside line that I'm rotating around. Okay, it's this blue line. It's this guy right here, but I want to get it in terms of x, so I got to divide by 4. So it is y squared over 4 minus the line I'm rotating around, which is 0. Okay, this guy squared minus little r squared. You still got to take that pi out in front. Don't forget to do that, but it's pi y squared minus, I'm just going to write all that because it looks kind of ugly. Boom, that guy right there. We take it, we type it in, we get an answer. You should have gotten 25.1. No? Thank you. 26.808. Questions with something we did today? You do 4.